Thank you, Bob. So at NASA's Johnson Space Center, we're just so super proud to be able to continue the legacy of doing spacewalks, as Bob mentioned, from Apollo heritage, using our suits for science operations, assembly of the International Space Station, and operations and maintenance that's ongoing. And now we're looking forward for our return to the moon and using our suits for doing science operations on the lunar surface. At Johnson Space Center, we have been working doing technology development in-house with our engineers and our operators on design for an exploration suit. We have provided all of that technology, all of the drawings, all of the data, all of the test results for the community. And Axiom Space will be one of the companies that is going to take that and make us new suits. We have not had a new suit since the suits that we designed for the space shuttle. And those suits are currently in use on the space station. So 40 years we've been using the same suit based on that technology. And now today, Axiom is going to innovate. They're going to take what NASA has provided in, from the testing that we've done, and they will now take and come up with more functionality, more performance, more capability, and we're very excited about what's going to be happening. At NASA's Johnson Space Center, we are proud to partner. We will be working together. We'll provide our expertise. We're going to provide all of our facilities, and we will be working together to make sure that we have a safe suit that performs and does everything that our astronauts need for doing surface operations. So we're looking forward to the things that Axiom is doing, and I want to thank the Axiom team. I want to thank the NASA and all of our teams that work together to make this happen. Thank you. And now I'm going to turn it over to Laura.
Hi, good morning. Glad to be here and to see you guys today. I am truly honored to be the manager of what Vanessa mentioned as the EVA and Human Surface Mobility Program here at Johnson Space Center. That for short means spacesuits and rovers. The spacesuits are the first part of our program that is becoming real. We've been working really hard for a few years to get everything on contract. But once that is in place and we actually have contractors selected, it's really excited to see their work coming to fruition and seeing real hardware. So this contract is a little bit different. It's similar to what we have used for commercial cargo and commercial crew, where we call it a service contract. So historically, NASA has actually owned the spacesuits. Think of it like owning your car. The way we have contracted on what we call the extravehicular activity services contract is we actually buy services from the vendor. So think of it more like a rental car. So Axiom will be providing the hardware for both training and for flight. They will bring that hardware in, and we, NASA, will utilize it and operate it on the surface of the moon for our moonwalking. So NASA will actually be in the role still of mission control and making the mission authority, mission execution decisions, but Axiom's going to be right there with us, making sure that suit is safe as we have our astronauts walking on the surface of the moon. So this suit, we have a lot of tough requirements on it, so these guys have their work cut out for them. The moon is definitely a hostile place, and the South Pole is going to really be a challenge. So a lot of thermal requirements. We are really looking for improved mobility so that our astronauts can operate more efficiently and effectively than they were able to do many years ago in Apollo. And then, of course, we have really stringent safety requirements, as Vanessa mentioned, on the suits as well. So they certainly have their work cut out for them, but we are absolutely confident that they are going to be successful. So our role as NASA is, as Vanessa said, to make sure that all of our expertise and our data and our facilities are made available to them. And then we will be in there hand in hand with them, helping make sure that they are successful, bringing all of our knowledge to the table, all of our experience, along with our friends from the crew office, just providing them our expertise and advice and guidance as they go forward. So super excited to have Mark and Russell and their team, and really looking forward to a few years from now when we see that first Axiom boot print on the moon. All right, we keep forgetting to introduce, so I think I'm going to pass it on to Mr. Mike Seferdini.
All right. Thank you, Laura and Bob and Vanessa, too, for being here. This is a big deal for us. Let me start by saying, Mark, when I look at here this sea of new astronauts, I think we're going to need some more suits. But first, let me tell you how pleased we are as a company. It's a huge deal to be selected to provide the lunar surface suit for NASA's Artemis program. It's an international program. We're not just taking the nation to the moon and beyond. We're taking we're taking civilization to the moon and beyond. And so we're pleased that humanity's next steps on the moon are going to be in an Axiom spacesuit, and we're very excited to be a part of this, the exploration mission as it goes forward. The other thing I need to say is, and they've touched on a little bit here this morning, but this is not something that you do by yourself. This is a partnership. It's a partnership with NASA. The design that we chose and brought forward is an evolvable design from the orbit suit to the lunar surface suit. It's based on about 10 years worth of work that's been going on at NASA Johnson Space Center by suit experts. And we're happy to have all of that expertise and that work done. I think when it's all said and done, about 50% of the suit will be based on the original design done by NASA, and probably the other 50% will be the work that this team sitting in the auditorium will do. So that's first and very, very important. And as Laura said, this is a critical system. It's like, you know, we all get nervous on launch day. Well, when you do an EVA, it's a significant challenge. And so it's very important that you have very strict safety guidelines and a suit that will provide the redundancy and the reliability you need to make sure every time a human steps foot on the moon, that they'll be able to do what they need to safely and get back and be ready for the next mission. So for a second, though, I want to take a moment to acknowledge the Axiom team, which is, as far as I can tell, nobody's working on suit today because they're all here. But could you guys stand up and be recognized? This is the Axiom Space team. You guys are awesome. And when I say Axiom team, it's not just Axiom Space, KBR, Paragon, David Clark, let's see, APT Research, SOFIC, and Aerosciences and Technology. Did I get them all? Airlock. And Airlock. Oh, goodness gracious. Airlock. Did I mention Paragon? I got left out IM too? All right. Sorry about that. Paragon, Intuitive Machines, and Airlock. Anyway, my point is we're a big team. We brought a lot of expertise from around the country to work together to build this suit. And it's a critical part of exploration. And we're extremely excited and proud to have been selected to go on this journey with NASA as it takes civilization beyond low Earth orbit. So with that, I think my job is to hand it off to Mark. We've been sitting here talking about all this stuff, but we have an exciting thing to show you, so Mark will get us started down the road. Go ahead.
Thank you, Mike. Yeah, so a lot of hard work has been completed for the team to be here today with the spacesuit. For the last couple of years, our team has been really focused on three things: people, processes, and facilities and equipment. Our team is comprised of many, many people from the NASA XEMU program, so they bring a lot of expertise forward. A lot of our team has worked multiple EVA programs. And then we leveraged industry, automotive, oil and gas, the theater arts, and even design from some of the I'm sorry, I lost my words. Professional clothing design. Thank you. So we have a vast base of really talented and experienced people. Our processes, you combine all that with Axiom's agile development process, and the team's able to move extremely fast. But in a very controlled environment, which is critical to building and designing spaceflight hardware. You couple that with using NASA's XEMU technologies, and it just makes the team's performance even greater for success. Axiom has a number of facilities. The most recent facility we have just populated or moved into is the EVA program facility. So the team is very excited about that. We've vertically integrated all the team members and Axiom under one roof. And we're about to open our state-of-the-art labs. We've been working in temporary space, which has been very accommodating. But we'll have everything we need to design, manufacture spacesuits for the lunar surface and for Axiom's space station. And with that, I just want to thank the EVA team on behalf of Russell and I. Thank you so much for all of your hard work. We thank your families for standing by as the teams work long hours sometimes. And we'd also like to thank Laura, Chris, Jesse, Ben. We appreciate all the collaboration with you and your team. The insight and collaboration has gone exceptionally well, and you guys are a big part of our success as well. Thank you. I think we're going to a video now.
The suits that are used today were developed several decades ago. Originally, they were developed for the space shuttle, and they're used in the International Space Station today, but if we want to go back to the moon, then we need a new spacesuit.
Spacesuit design has been really evolutionary for decades, and we're kind of taking a larger leap. We're changing it so it's dust tolerant, so that you can walk far distances, that you can help if your fellow crew member is incapacitated, the ability to bring them back with you. So all these updates were more of a revolution than an evolution of the current design.
I'm excited by some of the really new developments in technology that have been added in, and I think it's going to be a great suit.
It is an unbelievable amount of effort, from seamstresses to requirement specialists to engineers, managers. You have a range of skill sets, and everyone is so proud to be doing what they're doing.
It's like a little bit of each of us is going up there with the astronauts, and a little bit of our mentors, a little bit of our family. Like it's more than just ourselves, right? It's everyone before us and everyone after us. So that's, you can definitely feel it.
That gives you goosebumps, right? Like, that is, it hasn't sunk in yet, and I don't know if it will ever sink in. Even when it's happening and you're looking at the moon, and you're like, there's someone on the moon in an Axiom suit, like, that is the dream.
Space is changing so fast right now, and it's going to be such a great time to want to get into any aspect of the space program, whether, you know, as an engineer, a designer, an astronaut, somebody, you know, stepping foot on another planet.
And now the moment you've all been waiting for.
All right, good morning. My
My name is Russell Ralston. I'm the Deputy Program Manager of EVA at Axiom Space. In the suit here this morning is Jim Stein. Jim is an extraordinary engineer. He's our chief engineer on our team. So we gave him the honors. Yeah, go ahead. We gave Jim the honors of demonstrating the suit this morning. I'm going to give him this little walking staff here. We are in Earth gravity. We're not on the moon, if anybody doesn't know. On the moon, the gravity is about 1/6 of what it is here. So just in case Jim loses his balance, for safety reasons, want him to have that. So I'm going to talk through the suit design just very briefly. And as I do that, Jim's going to perform some different actions, mobility, to demonstrate the mobility of the suit. Before we get into that, though, I want to talk about this cover layer. So the cover layer that you see, the black, the orange, the blue, personally, I think this looks amazing. I want to thank Esther Marquise for helping us design this. Esther is a designer, a spacesuit designer on the show For All Mankind, if anyone has seen that on Apple TV+. So this suit has a lot of that worked into this. One of the differences between this suit and the suit that will be on the moon is that the moon suit will mostly be white. So we'll replace all the black with white. And that's really for thermal reasons, so didn't want anybody to get that mixed up. But other than that, I think this is just a fantastic, fantastic looking suit. So let me go top to bottom here and just describe the suit overall. So we'll start with the light band. I think you guys saw the lights as Jim walked out on stage. The light band is mounted to the visor assembly and to the helmet bubble. And this essentially gives the astronauts lights to see where they're in shaded portions of the moon, or if they're in low Earth orbit. In a night pass, they can turn on these lights to see using tools or translating on the space station or anything like that. We also have on the side here, we have a HD video camera. So those of us back on Spaceship Earth watching the EVA will be able to watch it in high definition, which will be a fantastic upgrade, I think, from current day technology. All of this is mounted on the helmet bubble, which is mounted to what we call, in this configuration of our suit, the hard upper torso. So the hard upper torso goes roughly from Jim's waist up to the top. And this is kind of the core structure of the suit. It's what we attach everything to. So the arms, I'll talk about the backpack in a minute. So yeah, if Jim wants to demonstrate some of the arm mobility here, this really just provides us, again, some structure to mount things to. Each of the arms have a variety of mobility joints and elements that we've designed at Axiom, including the gloves. The gloves are a critical part of the suit design, especially for microgravity EVAs, where you're using them for hours at a time to translate, to operate tools, to fix things to the suit and so on. So we put a ton of effort into those gloves, pretty proud of where they're at, and are confident those are going to perform very well. If Jim turns to the side here, some people may be wondering, hey, how do you even get in this suit? There's a hatch on the back, actually. You can see two hinges here. So this suit's a little bit different than the suits of kind of today that's used on the space station. So this is called a rear entry design or a back entry design. This hatch would open up. You would put your feet in, put your arms in, and then kind of shimmy down into the suit, and then we would close the hatch. Mounted to the hatch is this box, affectionately known as the backpack. We call it the portable life support system. So inside of this box are all the parts and the components to kind of keep you alive while you're doing EVA. You can think of it as like a very fancy scuba tank and air conditioner kind of combined into one. So on the lower torso, so let's start kind of from the waist going down to the boots. I'll let Jim do some squats and lunges and just show off some of the mobility that the suit has and demonstrate some different movements. There's a variety of joints that we've put as well into the lower torso assembly, and this is going to be a huge improvement over the Apollo suits. The Apollo suits didn't have many of these types of joints that we've put in this suit, so the astronauts will be more comfortable, have an easier time walking, performing tasks, getting down to pick up a rock or something like that, or use a geology tool. And then the other thing that, yeah, that's a great demonstration there by Jim. The other thing I wanted to touch on is the boots. The boots are critical part of the suit, especially for the Artemis 3 mission and missions to the South Pole of the moon. We'll be entering regions called permanently shadowed regions. These are regions of the moon that never see sunlight, and they're very, very cold. And so it's very important that we insulate the boots appropriately to keep the astronauts' feet comfortable during the EVA. That's a portion of the design. As Mr. Suffredini mentioned, there's many portions of this design that we've kind of adopted from XEMU and are continuing to refine. That's an excellent portion. The XEMU team did a tremendous job, and a lot of our teammates did a tremendous job designing those boots. So we're taking those forward and refining them to flight. Those are really a key aspect of the suit. I think I've covered everything pretty quickly here at a high level. I don't think I've missed anything here. So I know we've got some questions and answers that we want to go to, but before we do that, I'd love to introduce our Director of Human Spaceflight and the upcoming commander of AX-2 mission to the International Space Station, Peggy Whitson. Peggy has spent a lot of time in spacesuits, so welcome.
I'm so excited to be here today. This is a great example of what innovation can do. This is going to be such a much more flexible suit, and the range of motion is really going to improve the astronauts' ability to do all those tasks that they're going to do while they're out exploring on the lunar surface and eventually on Mars. That would be so special. And we are here today actually because of this young group of people here that are here for the Moon to Mars Festival. We think that it's really important that we get you guys started on your spaceflight training. And it's really important because we know that you're going to be our future and you're going to be able to wear this suit someday. So we're very much looking forward to that. And we actually have some really little special guests that are going to ask some questions. And I have somebody I'd like to introduce who's going to help us out with that. And this is my pilot, John Schaffner. We're flying. We're flying on the Axiom 2 mission that's going to the International Space Station in a few months. And John is here to help me out and get some young people up here to chat with you and ask a few questions about this suit.
Here we go. Well, I have the extreme pleasure of talking to myself in the past. I had an astronaut in me since I was 10. It took me a while, but because of today, the wait has been worth it to talk to some people today. First, I'd like to thank NASA and Axiom for making all of this possible in the private and commercial spaceflight endeavor. I think it's a great step, and we're going to introduce some kids to you that I think will be your future, both for Axiom, Artemis, and NASA. So, I'd like to bring these young people down here that have brought us some really fabulous questions. By the way, thank you, Peggy. I look forward to our flight.
I do too. It's going to be great.
Yeah. Looking good.
Come on over here, hon.
You know, this is great for me. This is actually my demographic, so I feel right at home. All right. Awesome. So what do you think? That's quite a suit, right?
Pretty neat, huh?
Good. Now, I understand you guys have some questions. Remington, you're 8 years old. You've been thinking about space for how long?
About a year.
Okay. So what is your question today?
Do you wear your space suit in space?
Oh, is that question for me? I'll take it. Well, I won't actually wear this suit. I might sneak back tonight and slip it on. We'll see what happens. But I think this suit will look great on you. So I'm looking forward to one day seeing you in space in this very suit. Would you like that? Cool. Good morning. You're Ian, right? Yep. Okay. How old are you?
I'm 5.
That's awesome. So you have a question for Russell, and Russell's right back here behind us. What is your question for Russell?
What's your favorite part about your spacesuit?
Oh, that's a great question. You know, if you're going to walk on the moon, I think you have to do it in some pretty cool shoes. So probably the boots. I think the boots are probably my favorite part.
He likes the boots. I like your shoes, by the way, today. Thank you for your question, Ian. You look good in this suit also. Hi, Charlotte. I met you a minute ago up there. You had a lot more to say then.
What?
So you have a question. I think it's for Peggy, right? You want me to help you? Yeah, I know she makes me nervous too. She's my commander, and she's a very famous astronaut, and it's okay. She has answers for everything. I've tried. So I think your question is, how far away is the Earth from Mars? Is that what you'd like to know?
I don't know.
You don't know? Okay.
That's okay. I don't either, but Peggy knows.
I think it's 120.22 million miles away. That takes a long time to get there. Maybe like almost 9 months, but I'd sign up. So.
How far does your grandmother live away? Thank you for your question this morning. Viz, good morning, sir. 10 years old. You're almost going to be 11, though, right? All right. Okay, for Mark. Okay, Mark is right back here, the gentleman that introduced the suit to you. Okay, what is your question?
What characteristics about the suit will help us survive in space?
Microphone.
What characteristics about the suit will help us survive in space?
That's a great question, Viz. So, as you probably already know, deep space can be a very harsh environment. And there's no oxygen, there's no atmosphere. So when we design our suit, we have to make sure it can keep you warm, it can cool you, there's oxygen for you to breathe, and even food and water. So those are all very important aspects of our new spacesuit.
All right, you've got it from the top. Thank you. Remington, back to you. You had another question. This one I think was for Russell. Is that right?
I'll take it.
Okay. Okay, we're working on it. We're almost there.
How long can you live in space?
How long can you live in space? That's a great question. So we've had people, or NASA has had people as an agency on this International Space Station for over 20 years. Some of those individuals have stayed on the space station for over a year at a time, but we don't actually know how long. So we need to keep exploring, need to keep building space stations and going back to space to figure out answers to questions just like that.
That's long enough for me. Great job. Thank you. Jane, over to you in the pink. Okay, you have a question for Peggy. I have questions for her too, but how about you first? What is your question?
How many times can you go on a space mission as an astronaut?
So I've been on 3 different space flights previously. They were long duration missions, and John and I are going to go on another mission together here shortly in a few months. And so that'll be 4, but I'm looking forward to any others I can get.
How many times would you like to go to space?
3.
Okay, we've got you down for that. Got you down for 3. Okay. Viz, last question's yours. Are you ready?
Yes.
Okay, this is for Bob, right behind you, Bob Cabana and Mike Suffredini, but these 2 gentlemen here. What is your question?
When will we see the spacesuit on the moon?
That is a great question, Vince, and NASA is working very, very hard to ensure that we keep Artemis 3 on track, and our goal is to have the first woman and next man back on the surface of the moon on Artemis 3 in 2025.
And they'll be wearing an Axiom lunar surface suit.
Awesome. How old will you be in 2025?
Sorry?
In 2025, when the suit is on the moon, yes. How old will you be?
23, 11, 12, 13.
Okay, 13, awesome. The Artemis generation, thank you very much, and we'll see you guys in class.
Thanks for coming up, sweetie.
Wow, that is super cool. Isn't it exciting? Let's do another round of applause for everyone. This is so exciting to be part of this. Well, again, I want to express heartfelt thanks to all of our panelists here. Congratulations to NASA and Axiom for this amazing milestone and achievement as we prepare to return humans to the moon in an entirely new architecture and program. And we can't wait for that day when we have the first woman and person of color and other astronauts step on the surface of the moon and really begin a whole new phase of adventure and science and exploration. So with that, that concludes today's program. Thank you for joining us. And I would like to invite members of the media to come to the front for a closer conversation. And we look forward to having all of you join us at the Moon to Mars Festival here at Space Center Houston. Again, it runs through Sunday of this week with live entertainment on Thursday, Friday, and Saturday night and Sunday afternoon. Again, thank you for joining us.
And here we go.
10.
Hydrogen burn-off igniters initiated. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond. And here we go.
10.
Hydrogen burn-off igniters initiated. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis 1. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison and shortly thereafter. Confirmation that the solid rocket boosters have separated these 177-foot boosters. Now the core stage continues to power the flight of Orion, all 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange.
And you're seeing there on your screen our first Earth views. This view of Earth captured from a human-rated spacecraft not seen since 1972 during the final Apollo mission some 50 years ago. The views of our blue marble in the blackness of space now capturing the imagination of a new generation, the Artemis generation. At 6:44 a.m. Central, just about 9 minutes and 30 seconds ago, commands were sent for the outbound powered flyby burn to occur with the Orbital Maneuvering System engine, or OMS engine, on board Orion, which sends Orion close enough to the lunar surface to leverage the moon's gravitational force and swing the spacecraft once around the moon toward entry into distant retrograde orbit. Following this, Orion will remain in the distant retrograde orbit for 1/2 elliptical orbit around the moon, which will last about 6 days.
Now to distant retrograde orbit, or DRO. We're going to be about 38,000 miles away from the lunar surface as we orbit around. That's part of why we're calling it distant. And we call it retrograde because the moon orbiting the Earth in this direction, and then we're entering into our orbit in this direction. Opposites, retrograde. Now we're choosing this orbit because it's extremely stable. It doesn't cost a lot of fuel to maintain your position there, and that gives all of our engineers, our flight controllers, the chance to really learn about Orion systems in deep space, learn about flying a spacecraft farther than we've ever sent one intended for humans. We're going beyond anywhere we ever went for Apollo. And so we're in that orbit, test out all of those systems. Eventually we'll do a maneuver to break out of that, do another flyby, and come home.
We're continuing to get some spectacular views from the Orion spacecraft. From this view, Orion is 1,277 miles above the lunar surface following its return-powered flyby burn, which sent it around the backside of the moon. Orion now has its sights set on home. This view is from one of the solar array wing or SAW cameras on board the vehicle. The vehicle now over 1,680 miles away from the moon. And that small sliver towards the bottom of your screen, that's here, that's home, that's us. And that is where Orion is headed next.
"50 years ago today, Apollo 17 Commander Gene Cernan and Lunar Module pilot Jack Schmitt guided Challenger to a pinpoint landing on a barren rock-strewn area of the moon called Taurus Littrow. A half-century later, NASA's newest moon explorer, the Orion spacecraft, is barreling its way back home after circumnavigating the moon and beyond in an elliptical distant retrograde orbit, now less than 2 hours away from splashing down in the Pacific Ocean west of Baja, California, to complete its shakedown mission that has opened a new era of deep space exploration." Thank you, Philip. And again, a live view of Orion closing in on planet Earth, now about 11,000 miles away from Earth, as it continues a very, very precise trajectory for a splashdown that is scheduled at 11:39 and 42 seconds a.m. Central Time this morning. Now just 1 minute away from crew module, service module separation. We'll be standing by for confirmation of that from the 10 seconds until SEP. We have confirmation of separation. Orion flying on its own. Again, the separation occurred right on time at 11 a.m. and 11 seconds Central Time, with Orion 3,200 statute miles away from Earth. The European service module has done its job. Just 1 minute away from entry interface. And this view from the cabin camera Looking out of the upper hatch of Orion, you can see the limb of the Earth. We're going to be losing all of the data here shortly once we enter into the Earth's atmosphere and begin the first of the 2 blackout periods. Again, this is a visualization of what should be happening with Orion at the moment, although we are in a blackout period that should end about 3 minutes and 15 seconds from now. And we have data from Orion. Orion out of the blackout period. Flight Dynamics reports that Orion is right on the money, coming right down the pike. A good view out of the cabin camera looking out of the upper hatch of Orion. We should be performing the skip entry maneuver momentarily. Good communications established with Orion. This view on the deck of the USS Portland. And there is a view out of the cabin camera of Orion as it continues a series of role reversals. We have data back from the spacecraft. Flight Dynamics reports Orion straight and narrow on a true course toward its splashdown site. Forward bay covered jettisoning less than 3.5 minutes from now. $150,000 feet off the ocean. Orion now traveling at Mach 10. Orion now at 50,000 feet. Forward bay covered jettisoning pyros are armed. $25,000 feet. Drogues have been deployed. Two good drogue shoots reported by the recovery team out in the Pacific. The descent rate is right on the money. Orion's velocity now down to 282 miles an hour. Range to splashdown 1.5 miles. 10,000 feet now. And we're on mains. 5,000 feet. Reefing in progress. 3 good main chutes for Orion. We have 3 fully inflated main chutes. Time to splash down 90 seconds. Perfect descent rate reported. And there it is, high over the Pacific, America's new ticket to ride to the moon and beyond now in view. Orion under its chutes descending toward splashdown. Orion in the perfect orientation for splashdown, just seconds away. (1,000 feet). Good descent rate. (500 feet). Splashdown. From Tranquility Base to Taurus Littrow to the tranquil waters of the Pacific, the latest chapter of NASA's journey to the moon comes to a close. Orion, back on Earth. Orion is in great shape, stable 1, just in the orientation that had been expected.
Please raise your hand so we can make sure we get you the microphone as well. Please give us your name and your outlet to begin with, and then your question.
Mark Carreau, the Aviation Week. When do you expect this this version to be in space? And I presume on the space station, and what would you do at that stage in order to evaluate?
There we go. Test 1, 2. Test 1, 2. Thanks, Mark. So first off, Axiom is building their suit to go to the moon. This is the lunar surface suit, and we hope to have it on the moon in 2025 with Artemis 3.
Will you test it, though, on the space station?
I could take it, or do you guys want to?
Yeah, sure, I'll take that. So this suit that's designed for the Artemis 3 mission will not be tested on the space station prior to that mission. We will do an extensive set of ground testing and qualification program to make sure that the suit's bulletproof and safe to go on that mission. But no, we won't take it to the space station first.
Our next question, I believe Fox has a question from the floor over at the camera as well. Any additional questions for Bob Cabana as well, we can take those at this time. Meredith, if you want to take the microphone over to our camera over here. We have a question about the sizing.
Oh, yes. The new designing for women in particular, can you talk about what went into that, the differences, and what that design will be like?
Sure, yeah, I can speak to that. So we've put a lot of effort into the sizing of this suit and paying attention to how we design different joints in the suit to accommodate anybody, first percentile female to 99th percentile male. There's kind of two parts to that. There's getting the size to where they can perform a range of motion for a given task. And then the second part is making sure that when they perform that range of motion, it's done in an easy way. It's not very hard where you're fighting the suit and that type of thing. So we have a variety of test subjects at Axiom that we put in the suit. Lots of people who have been in the suit for a long time, tested many different prototype spacesuits. We also put crew members in the suit to test this, and so we'll basically take a lot of different test subjects and crew members, put them in the suit, evaluate designs, and refine them to make sure that the suit performs well for any individual who's going to get inside the suit.
So basically, it's going to be this same suit, custom fit to each person, male or female. Is that correct?
That's close. So it's not quite custom fit. We have the capability to do that, but what this design does is essentially a kind of a macro and a micro sizing. So we have different sizes of elements that we can swap out, a medium, large, and small, if you will, for different components. But then within each of those sizes, we also have an adjustability to where we can really tailor the suit to someone's, the length of their leg or the length of their arm or things like that. So we have a lot of sizing capability to adjust the suit for their particular body.
And just a little bit more of what you were expressing during the public speaking about the flexibility. You were talking about how he's able to bend up, pick the samples up, and just the improvements from the older.
Sure. So I would say that both at Axiom and at NASA, there's been a tremendous amount of work that's been done in the past to improve the mobility of the suit. A lot of that was done through various prototype suits, years ago through the XEMU project, and we're doing the same thing at Axiom. And so we mentioned a partnership earlier. We're really working together to find the best architecture to give the astronauts the best mobility possible for the tasks that they need to perform. And so we look at those historical designs and learn from those in the previous testing that's been completing, in addition to trying new ideas out that our team has inside the lab, testing those inside our lab or inside different environments or different facilities, that NASA has or that we have. And so essentially what you do is you look at what's been done in the past, you learn from that, and you try some new ideas, and we just kind of iteratively improve the suit over and over and over again, making tweaks here or there as we learn new lessons.
Some instructions for our phone bridge friends as we move the microphone up the stairs for a question up at the top of the stairs. If you're on the phone bridge, please press *1 if you have a question, and after you are done with your questions, you can hit *2 to withdraw your hand. We have a question in the room. Sir, your name and your outlet, please.
Hi, Robert Perlman with Space.com and CollectSpace. Two questions, somewhat related. Can you give an example of what was brought over from the XEMU research and what is new from the Axiom contribution? And then just in general, in terms of donning and doffing the suit, can a single individual put it on themselves? Do they need assistance like right now with the EMU? And how is it put on? How many different parts are there?
Sure, yeah, great question. A couple examples of areas where we've kind of directly transferred technology from XEMU. The boots are one of those. The hard upper torso of the spacesuit, NASA put a tremendous amount of effort into designing that hard upper torso. And so we looked at that design. We've tweaked a couple minor details, but in large part, that was a direct transfer, helmet bubble. But the rest of it, soft goods and things like that, we've designed in-house at Axiom, our own patterning, our own designs, obviously in collaboration with NASA and talking with NASA, but those are internal components that are a little bit different. The gloves are different. We've changed how the gloves are made and the design of those, so that's an Axiom unique product. As to how you get in and out of the suit, there's a hatch on the rear of the hard upper torso, and that hatch essentially swings open just like a door. It has 2 hinges and it swings open. And so you would put your feet into the suit, kind of sit up on the suit, and put your feet in, put your arms in, and slide down into the suit. So a single person will be able to don the suit. We're currently actually putting some features in to enable that, so they can self-close the hatch and then self-index themselves inside the suit. You can think things like shoulder straps and that type of thing. So we're still working on a couple of those elements, but we've made some good progress toward them.
Just to follow up, given the use of the hatch, are you envisioning this being used with a suit lock of any sort with the vehicles that are being developed?
Sure. So the current work that we're doing does not involve a suit lock or a suit port or anything like that. Certainly a rear entry design would be what you need to make that type of idea come to fruition, but currently we're not working to that.
Another question down here in the front, and then we'll go to our phone line. If you do have a question on our phone bridge, please press *1 to indicate you have a question.
This is Mark Carreau again with Aviation Week and Space Technology. How long will an astronaut be able to function in this suit? And I'm interested in the sorts of advances that you've tried to make in mobility, dexterity, communication, and also situational awareness that the astronauts can obtain in this suit, the objectives.
So I heard a couple questions there. Can you repeat your first one? I'm trying to keep track of.
Well, let me skip.
I think it was how long? Did you say how long they can be?
Yeah, how long can they wear the suit on a mission, given, sort of estimated capability? And then, again, I'm talking about the advances you're striving for in terms of mobility, dexterity, communication, and also situational awareness.
Gotcha. Okay. Yeah. So the first one is pretty simple. So we're designing the suit for 8 hours and a nominal 8-hour length. Certainly, in the right conditions, the suit can go longer than that. But it's a step, kind of a step up from the current day spacesuits. The current day suits were designed to 6.5 hours and a lower what we call metabolic rate, basically how hard you're working in the suit. So we designed to a higher metabolic rate and 8 hours in this suit. So honestly it's a pretty huge step up in performance in terms of EVA capability. Situational awareness is a good topic to talk. That's critical for astronauts, especially while they're EVA. This is a very dangerous operation, of course. So we've incorporated some features, and again, some of these are things that have transferred from XEMU. So if you look at the helmet bubble and the visor assembly, if you were to kind of do a side-by-side between that and the current suit, you'll notice that there's much more clear vision in this helmet bubble. The visor assembly has been kind of compacted back to the rear of the helmet bubble. That's something that XEMU worked towards, and that's something that we're kind of taking forward and refining. And what that does for you is gives you much more situational awareness, much more visibility, especially for low Earth orbit EVAs, where if you're translating and you're kind of looking up, your view isn't blocked by the visor itself, so you're having to move your head more, move the suit more. So it makes translation in a microgravity environment more intuitive.
Any additional questions in the room? Once again, we're going to go to the phone bridge, *1 to indicate that you have a question. At this time, we don't have any questions on the phone bridge, so I'm going to move on to Fox 26 in the front row.
This is just kind of a basic question for the purpose of my story for the audience. If anyone wants to speak about the partnership between NASA and commercial in general and the benefits of this in a situation such as what we're witnessing today.
Yeah, I can take that one. So again, we talked about earlier this morning that this is under a service contract. And so Axiom retains ownership of the hardware. And again, we are working in collaboration to develop the suit to make sure that it does meet the NASA requirements. But outside of that, we actually encourage Axiom and any ex-EVAS contract vendor to go out and look for other commercial customers that can use this suit. And what that does at the end of the day is reduce the cost to the government as we can cost share across other customers that they have.
And there's a question behind, I'm sorry, go ahead. Go ahead.
And so I would just add that because Axiom is building a commercial space station, we also need an EVA capability. So it fits really, really well with our business model, and we're building suits for both NASA, for Artemis, and then for Axiom, for EVAs. Yes.
There's a question behind you.
Hi, David Phillip with the Associated Press. I just want to know what's different between the outer layer and the underneath layer. I mean, is it just color, and what kind of design differences?
Yeah, great question. So there's actually a lot of layers to the spacesuit. In general, you have an inner layer that's called we call it the bladder layer, and that's what holds the air inside the spacesuit. Okay, so you can think of it like a balloon almost. Outside of that is what's called a restraint layer, and that layer holds the shape of the balloon so that it holds the air pressure and kind of takes the load of all the inflating the suit. Then from there you have essentially an insulation layer that's actually made up of a bunch of different layers on top of that. So that's one of the differences that you won't see on this suit. This suit does have the same bladder layer and restraint layer, but the insulation layer is different. So this is what we would call a cover garment that we use to protect the inner layers of the suit during ground testing or training or things like that. For space flight, we need to protect the astronaut from the thermal environment of space, and so the insulation layer really helps protect against the sun rays and UV light and things like that. So there's a variety of materials that we use inside of that layer to do that job. And then for the Artemis 3 mission, we're also doing some proprietary things to that layer to help with dust, because dust is going to be a huge problem when we go back to the moon.
Excellent. We have 9 questions on the phone bridge, and we have one more in the room, so I'm going to go to the phone bridge. I'm going to start with Alicia Saws from Mashable. We're going to unmute your line, and you may ask your question at this time.
I'll take it. That's a great question. This is probably an area where I might say, if it's not broke, don't fix it. So, yeah, we're still using diapers in the spacesuit. They're just honestly a very effective solution. Sometimes simplicity is best, and this is one of those cases. So yes, today's suits currently use diapers, and we're envisioning the same for the future.
Okay. Moving on to the Houston Business Journal and Jishun. You may go ahead and ask your question.
I think the question was, how are we incorporating new technologies from previous research into this suit? That's at least what I heard. Okay, I'll speak to that a little bit, and if anybody else wants to jump in. Yeah, great question. So there's been a lot of research and development that's gone on, both in the private industry, but also especially inside the government as well, through the XEMU project and then projects that preceded it. So at least in terms for Axiom and how we kind of approach suit design, we look at all of that work that's been done, the technology development for different components of the suit, and then when we architect this solution, we look at what makes sense for the type of suit that we're building, given the requirement set that we have. So the requirement set we're working to is slightly different than XEMU, so we expect to see some changes. We also look at data from various payloads that have flown. So NASA's actually done a tremendous amount of work at flying payloads like the SURFI payload experiment that tested different technologies on the International Space Station. kind of more at a component level, still integrated. So we look at all of that data and we look at all those technologies and assess where they're at in terms of maturity, and then we decide what makes sense to put into our suit, given the requirements that we're working to, the schedule we have, and a variety of other factors.
Looks like we're having a little bit of an issue with the audio from the phone bridge making it to NASA TV, so if you give me a moment to restate the question on the microphone before you answer. Our next question is going to come from Jim Siegel of nasatech.net. And again, give me a moment to repeat the question once it's asked. Go ahead, Jim. Must be a rocky place full of sharp edges. Are there any advancements in tear-resistant technology that this suit has over the Apollo era?
Sure. Great question. So yes, you're correct. The lunar regolith, the rocks, things like that, they are very, very sharp. And so obviously when you're walking around in an inflatable suit, these are things you pay attention to. I talked a little bit before about the insulation layer of the suit. The very outer layer of that suit is comprised of a number of different fabrics, and many of those are specifically designed to prevent puncture, tear. They're tear resistant, prevent scuffing and things like that. And to make sure that the fabric selections that we choose and the way we design it on the suit is going to work, we do lots of testing in the house, sometimes at an integrated level where we take the suit and test the entire suit, but oftentimes we take samples of the fabrics and test those, and there's just a whole suite of different tests that we do to look at the durability of a given fabric and the materials in that fabric. That's one of the major ways you kind of work against the risk of getting a puncture or a tear or something like that from the lunar surface or any other. The same thing applies on LEO as well, the low Earth orbit.
Great. Our next question comes from Chris Davenport. So the question is this the same suit for the EVAs? Why is there a covering on it? Is there proprietary information that you are keeping? Eventually, this suit will not have this covering, so why not just show it off now? And if you could, please give us your name and your title.
So this is Mark Greeley, the program manager for Axiom. So our architecture is the same for lunar and for LEO. There are some things that'll obviously be different. When you go to lunar, it'll have a protection garment on the outside. It won't have the cover layer that we're demonstrating today. The boots that we have today are very similar. The gloves are very similar. For ISS or our commercial space station, or if we have the opportunity to support NASA space station, we will likely have different boots and perhaps different gloves. The cover layer may be very similar, but the suit itself is very close. The base configuration is very close for lunar or LEO. And you are correct. I mean, we are in competition with Collins, so there are things that we haven't revealed below the suit, which is proprietary to Axiom.
We're going to our next question on the phone line. If you could, please tell us your name and your outlet before asking your question. is, how are you mitigating dust? Will you be packing extra when we go to the moon? And please acknowledge who you are.
Sure. So this is Russell Ralston, Deputy EVA Program Manager at Axiom Space. Excuse me. Great question. So yeah, dust is going to be a pretty tricky problem to deal with on the lunar surface. So we attack it in a couple of different ways, and I'll try to give you the best answer I can while still acknowledging we are in competition. So when we look at the way we design the suit, we look at a couple of different ways to tackle dust. One approach is to prevent dust from coming onto the suit. So looking at different treatments or things that we can do to the suit to prevent dust from adhering to the suit in the first place. That being said, we know it's going to adhere to certain areas, and so what we do then is we look at how can we keep that dust from then liberating off the suit once it comes back into the lander. Because as long as it stays on the suit, it's fine. It's not a hazard to health or things like that. But what we don't want to happen is for that dust to come off the suit and then get into the air and things like that. So that's definitely an integrated problem that will work with the lander providers. But as far as the suit goes, we have a couple different techniques that we'll go through in terms of cleaning the suit and then putting some devices on the suit to make sure that the dust doesn't come off and liberate into the atmosphere. And then to the question about, are we going to fly extra suits or things like that? One of the approaches we look at is intentionally making portions of the suit sacrificial. So you'll see this type of idea in racing where, on the helmet visor, they'll have tear-offs essentially. So as dirt and dust gets on the helmet visor, they can just tear off a new portion and see clearly again. So taking that same type of idea and applying it to the suit, I envision we'll have a few things like that. And so, of course, we'll work with our logistics teams and with NASA to come up with the right sparing strategy for those kinds of components and components that we expect, might not make it the full mission, if there are any, once we get through the full analysis.
Okay, our next question comes from John from Popular Science. John, are you there? Can we go to John? Well done, John. Okay, next up is Lucy from AFP. And after Lucy will be Alan from Al Jazeera English. Bit about the fabrics, please.
Can you hear me? Okay, good. All right, so yeah, this is Russell Ralston, EVA Deputy Program Manager at Axiom Space. So you're correct, the temperature environment on the lunar surface is a pretty extreme environment. It goes from several hundred degrees positive Fahrenheit to, in the shade, several hundred degrees negative in the Fahrenheit range. And so as you walk in between those environments on the surface, you're dealing with large temperature swings. And so we do have to select, I think your question's correct. We do have to primarily work against the temperature extremes with material selection. So which fabrics we use, which materials we use on the suit, and then how we build up the insulation layer to provide most of the resistance to the temperature change. Fortunately, most of that, hopefully this isn't too technical, most of that heat transfer is radiation, so our insulation is really targeted against radiative transfer, except for the boots. And so earlier I was talking about how it's really important on the boots that we design those in such a way, because your feet are kind of constantly in contact with the surface, or if you kneel down and your knees inside your suit touching the surface, there's some insulating materials that we're applying in different areas to help prevent the crew member's skin from becoming too cold or too hot or things like that. So it really does come down to material selection and the fabrics that we're using on our suit for the actual insulation layer help address that particular concern, both for the cold and for the hot.
Excellent. Our next question comes from Al Jazeera and Alan. Alan, are you there? So what is revolutionary about this suit, and what can we use from the suit design and product that could be used on Earth for healthcare workers or first responders or people in cold climates?
Yeah, great question. Again, Russell Ross from EVA Deputy Program Manager at Axiom Space. So it'd almost be easier to tell you what's not revolutionary because so much has changed, especially if you were to do a side-by-side comparison to like the Apollo suits. Some of the changes are in the soft goods side. So if you look at the spacesuit itself, the joint designs are all brand new, and again, a lot of them were developed in-house at Axiom. Probably the easiest examples to give are some of the components in the life support system, though. There are components. One of them I'll call the spacesuit water membrane evaporator. That's just the title we give it. This device helps us provide cooling to both the avionics inside the suit and the crew member themselves. That component was in development for gosh, I don't know, almost maybe 2 decades, something like that. That component is remarkable new technology that we're using in our suit. And so that's what we mean by revolutionary. It's not taking in many cases, it's not taking a piece from, say, the current spacesuit and just kind of tweaking it and upgrading it. There's cases here or there of that, but in large part, the life support system is totally brand new. It leverages lessons learned from previous suits. So we obviously study what types of failures have happened in the past and what's worked well and what hasn't worked well. But almost everything inside the life support system is totally brand new.
And any uses for these revolutionary products that could be used here on Earth?
Great reminder, yes. So one of the things we do at Axiom as a commercial company is constantly look at where can we apply these same technologies to other industries or to help. You gave the example of healthcare workers or other things. So yes, we take each of those technologies, a lot of them in the life support system again, and we look at different industries of where those could help. And so I think in the coming months and years, you'll see more clear examples of that.
Our next question is going to come from the Discovery Channel, but first I'm going to go to a question here in the room. Go ahead. And can you tell us who you are and who you're with? There we go.
Okay, hi. Andrea Leinfelder of the Houston Chronicle. I just wanted to follow up a little more on the cover versus protection layer, just so when people see these photos, I can explain to them that exterior is not what's going to be on the moon. So can you tell me just like what this cover layer is and how a protection layer might be different, if that makes sense?
Sure, yeah. So the easiest example is this is what's on the suit for the ground testing and training, and it protects the bladder layer and the restraint layers of the suit and the joints and things like that. So it's like wearing a jacket. It's just another layer that goes on top that protects you in jacket case from being cold, and in this case from scuffs or bends or whatever else happens while we're testing the suit, bending down on the ground or something like that. So it's pretty simple. It's just a fabric layer that protects the inner layers of the suit. The insulation layer that we've developed is much more complex. So it has, I won't give the exact number, but it has a variety of layers to it with different materials sandwiched and kind of laminated inside of it, and that helps with a radiation heat transfer, essentially. So one of the materials that we put in there is called aluminized mylar. Sometimes you'll see this in people's like attics in their homes. You'll have this like metal-looking film that gets stapled up on the rafters, and that helps with heat insulation. So we use that in part of that insulation layer. So whereas this is kind of a single fabric just for basic protection purposes on the ground, the insulation layer is providing the flight insulation layer is providing cut resistance, puncture resistance, thermal insulation, and a variety of other features. So it's a much more complex part of the suit, and well, we kind of tailor that layer to different portions of the suit based on what's on the knee might be a little bit different than what's on the backpack, so to speak, things like that.
Our next question comes from the Discovery Channel, and I'm going to go to David on the phone, and then we'll have 2 more questions on the phone and 1 more here in the room. So we're going to David on the phone. It always takes a moment.
Okay. Mark Greeley, Axiom EVA Program Manager. So I did mention around 50/50 the pressure garment system. The entire soft suit is an Axiom design. The gloves are an Axiom design. And then there are some other components that are beneath the cover layer that are really proprietary to Axiom that we've changed based on trade studies. In many cases, as we've talked today, we use NASA's technologies. And if there are areas where the technology wasn't fully mature, we iterate on it and try to bring it to completion in terms of maturity so we can use it on the suit.
Okay, and our last question, I believe, from the room.
This is also going to be our last question for today. We're rounding out today's program. This is Robert Perlman with Space.com and CollectSpace.
Thanks. Comparing this to what we know from Apollo, the Apollo suit was one piece in itself, but then it was augmented by pockets and mounting points for cameras and everything else. Realizing this is not the final version of the outer layer, but how much of that other augmentation do you anticipate for this suit? And is it Axiom's responsibility to provide the pockets and the attach points, or will NASA be augmenting the suit for its own needs?
Yeah, great question. So we'll provide, I'll answer the last part first. So we'll provide everything, the whole suit, EVA tools for the lunar surface, and everything that goes with it. So yeah, we do have the insulation layer design with different pockets, things that we call kind of multi-purpose attachment points that can be used for crew rescue if needed, or other things like that, carrying tools and things like, and other devices if they have a payload they need to take out or something like that. So you'll see a lot of features when we reveal that particular flight outer layer that is included in our part of the design of the suit. So we'll have 100% design influence on that, and obviously working with NASA and provide that to them.
And one quick follow-up, if I can. Similarly, with the visor, do you anticipate, are we going to see another gold visor like we did on Apollo, or are you, because we're going to the South Pole, is clarity more of a priority?
Yeah, good question. We'll still have a visor that provides UV protection to the eyes. There's still portions of sunlight on the South Pole, so anytime you're in that, we'll probably have that down. In addition to hard visors, just like in your car, right? So if the sun's just bothering your eyes, you can put those visors down and block that temporarily if you want to.
If there are additional questions, you can always reach out to Axiom Space at media@axiomspace.com. Thank you for joining us. Thank you for sharing your wonderful questions, and thank you to the entire team, and congratulations. Thanks so much.